Hi. Thanks for coming to my talk. I'm here to talk about the Internet computer. It's something being developed by an organization called DFINITY. It's a not-for-profit foundation based in Switzerland. It has research centers in Zurich, San Francisco, and Palo Alto. And I'm talking here because the Internet computer is a future stack. To understand the reason for the Internet Computer Project, you have to reflect on the history of the Internet from the 1990s. Back then, there were competing visions for what a shared network should look like. AOL and CompuServe offered walled gardens. Microsoft proposed the information superhighway. But in the end, the world preferred the Internet, the open Internet, because it provided an open, permissionless environment that provided a platform for creativity, innovation, entrepreneurialism, investment, and ultimately all of the economic growth that we see here at Web Summit. So the Internet computer is created in a similar way to the Internet. The Internet is created by a protocol called IP, Internet Protocol, and this combines thousands of private networks around the world to create a single virtual shared public network. The Internet computer is similar. It's created by a protocol called ICP, Internet Computer Protocol, that will combine thousands of independent data centers around the world to create a single global shared virtual public computer that provides functionality approximately something like a serverless cloud. So today, we only have a thin Internet that provides connectivity. And if you want to host, run a software system or internet service, you have to upload it to a gigantic room called a hyperscale data center, which will be owned by one of a small handful of monopolistic cloud providers. The environment that you run your enterprise software system in or build an internet service in is made more monopolistic because big tech has built out services that have corralled user data and user relationships. And most likely, you will also have to build your systems or services on top of big tech's APIs. So the Internet computer takes the world to a different place. On the Internet computer, you can, for example, recreate Internet services in open form, where they run without an owner as autonomous software. Oops, that's interesting. Let's get back. And they can provide guarantees to users about how their data is processed. And they can provide guarantees to other services that want to integrate with their that's not me touching that, with their user data and functionality. So why is this important? Incredible. Hold on. Let's see. So, when you build a new service on top of the APIs of big tech, you really are building on sand as an entrepreneur. And for example, if you created a business service that incorporated professional profiles from LinkedIn, a few years ago you'd have had a problem. LinkedIn revoked API access for hundreds of startups. And actually, if you go right the way through the tree, I mean, thousands of products and services were suddenly left high and dry because they didn't have access to these professional profiles anymore. And this reflects a more general collapse in what was previously termed the programmable web. So what can happen when you suddenly lose API access or the platform that you're building on changes? Perhaps one of the first big harbingers of what was happening was the problem Zynga encountered. So Zynga, of course, was a very successful social games company. They built on top of Facebook, and they IPO'd. They were worth almost $15 billion at their peak. And then Facebook changed the rules, changed the APIs from under them. And within 3 months, Zynga lost almost 85% of its value. And that's why if you go to a VC today with a proposal to create a new startup, and that new startup depends on the APIs of big tech, they'll likely laugh you out of the room, because what have you got? You could invest all this money and all this time building it, but if the APIs change, you're screwed. And the uncertainty involved in that platform risk means that it's difficult to raise funds and build these new enterprises. So to see how widespread this problem is today, you can look at the S1 filings of the recent tech IPOs. 17 of the last 22 tech IPOs actually cite platform risk as existential threats. Imagine that. 17 of the last 22 tech IPOs cite platform risk as existential threats. And there's a kind of inflection point being approached. People are becoming aware of this problem. Here you can see VentureBeat called Tech Monopolies, a Cancer on American Capitalism. The Wall Street Journal said that tech giants have hijacked the web and it's time for a reboot. Well, of course, that's what the internet computer is trying to do. So just talk a little bit more about what the internet computer will offer you as people building enterprise IT systems and new public internet services. Essentially, it's a completely new technology stack for building enterprise IT and internet services. And it sort of reimagines software, and it has a mission. The first part of the mission is to support autonomous software. So autonomous software runs without an owner, and it's what enables you to create open internet services that can provide these kind of guarantees to users about how their data is processed, but also to other services that might want to integrate with your profiles. So it's too late to integrate with the business profiles on LinkedIn because they already revoked everyone's APIs. But if you went and created an open LinkedIn using autonomous software, you could guarantee that the business profiles that you held would always be available to other services that wanted to integrate with you. And this can create fantastic network effects for new ventures. Secondly, the internet computer provides security by default. It was quite interesting listening to the preceding panel on DevOps. The internet computer provides a tamper-proof environment. It's created by a secure protocol that depends on mathematics for its correct operation, and it can withstand, for example, large numbers of data centers failing arbitrarily, and the thing just continues without a hitch. And within this tamper-proof environment, software runs with all of the security guarantees of smart contracts, which means the instructions that you expect to run always run, and it always runs against the data that you expect it to run against, and it always modifies that data in the way you expect it to. So you can build, for example, enterprise IT systems that don't rely on VPNs and firewalls and security teams for their security. It's secure by default. So that kind of turns things on its head a little bit. Thirdly, of course, the aim of the internet computer is to free captive customers. You know, if you're an enterprise, whether you're building just enterprise IT or whether you're creating a public internet service and you build on a big monopolistic cloud provider, you'll find it very difficult to move from that cloud provider to a new cloud provider. You become a captive customer. It's more than that, though, of course, because you're probably going to use proprietary databases and middleware servers and this and that. And all of these components can make you a captive customer. The purpose of the internet computer is to save you from being a captive customer, to allow you to build directly on the internet without need for many of these proprietary components. And that brings me to the fourth point, which is just reducing complexity. The internet computer reimagined software. And one of the aims here is to reduce the cost of developing systems and maintaining them, reduce time to market. It's interesting, if you look at a Fortune 500 company's IT spend, and you break it down, you'll find 85% is IT operations. So 85% of the cost is people. And then you break down that 85%, what are people spending their time on? Well, guess what? 90% or more of their time is dedicated to dealing with complexity. I.e., 90% of their time is spent focusing on the how rather than the what. The internet computer reimagined software, and it wants people to focus on the what, not the how. So just to finish up, you know, we talk about the internet computer running software with superpowers. Essentially, it's a seamless universe for software to which you can upload software to create an enterprise IT system or internet service where your software can call into the functions of any other software in that universe if it has the right permissions, where you can make your software autonomous if you want to create an open internet service, where the software runs within a tamper-proof environment where it can't be hacked, so you can create secure systems without VPNs and firewalls. And it introduces next-generation features like orthogonal persistence. Now, orthogonal persistence is a very techy-sounding phrase. It actually means something rather simple. So on the internet computer, you might be surprised to know there's no storage API. There's no file system. And we don't expect anybody creating systems on the internet computer will need, for example, a database. In fact, you couldn't take a traditional database like MySQL and run it on the internet computer. Orthogonal persistence essentially means that the internet computer is persisting the memory pages that your software runs in. And that means you as a software engineer, if you are a software engineer, can just write your code in the abstract. To give you an idea what that means, say you wanted to create some kind of very basic social network. In your code, you would write, you declare a global variable people. You would say var people equals new dictionary string comma profile, i.e. you just declare a data collection that maps a username to a profile object. And that would be it. The internet computer would ensure that your software objects persist by persisting the memory pages. And that contrasts with today's IT stack, where, of course, you'd have a database system and you'd be constantly packing data into some query, sending it off, getting the results back, unpacking it, and so on. All of that's gone. It's a great simplifier. But I think the thing I'd like to leave you with, because there's a lot we could talk about, is just some reflections on autonomous software. Autonomous software essentially is software that has no owner and can be controlled and updated by an open governance system that allows you to create something akin to open source internet services. There is a business model that can be used to return profits to entrepreneurs, but the end game is that you create something that isn't owned, an internet service that runs as part of the fabric of the internet. And the reason this development is so exciting is not only can these services provide guarantees to their users about how their data will be processed, they can provide permanent, irrevocable APIs. Which means that if you create something like an open LinkedIn, you can provide an API for other services to integrate with the professional profiles that you host, such that hundreds or thousands of additional services can be built on top without incurring platform risk. And I believe that this is what's going to drive the new internet forward. Mutualized network effects, where it becomes much easier to collaborate and extend services and build new value. And this will unleash a new wave of entrepreneurialism and investment into the internet. If you'd like to find out more, follow me, go to my website. Thanks for listening.